Divide the following rational expressions. State all non-permissible values. Just as with dividing fractions, to divide rational expressions, take the reciprocal of the divisor, which is the second rational expression, and change it to multiplication. As an example, for x minus 1 over x plus 2 divided by x minus 1 over x minus 3, the first rational expression remains unchanged. The second rational expression is changed, though, to x minus 3 over x minus 1, and we change it to a multiplication question. If the expressions on the numerator and denominator are not already factored, then factor them. To do this, we could use the greatest common factor method, trinomial factoring, or the difference of squares method. We now do the same steps as if it was simply a multiplying rational expressions question. So we multiply the numerators by each other and the denominators by each other. We then cancel the factors that are common to the numerators and denominators. Non-permissible values are the values for the variable for which the expression is undefined. Recall, this has to be applied before any cancellation of the factors. For the first question, 15a cubed b over 4a divided by 20b times 9a cubed. We first change it to a multiplication question, and we take the reciprocal of 20b over 9a cubed. We can then do some cross-canceling. Note here that the 20 and the 15 can be reduced to a 4 and a 3. We've got an a on the bottom of the first expression. We can then reduce the a to the 3 on the top to an a squared. We have a b on the numerator of the first expression and the denominator of the second expression. Those can be cross-reduced. We then have a final expression of 27 a to the 5 over 16. As far as our non-permissible values, we have a cannot be equal to 0. This because we have a on the denominator of the first expression as well as on the denominator of the second expression. We also here have to consider the numerator of the second expression. Note that because this is a division question, we cannot divide by 0. If b was equal to 0, then the entire second rational expression would be equal to 0, and then we'd again have division by 0. For example b, in this case, we have to do the factoring first. Although here first, before I do the factoring, I will change it to multiplication. So again, note I'm taking the reciprocal of the second rational expression. Note you could have done the factoring first and then changed it to multiplication. We can then factor. So we factor the numerator of the first expression, giving x plus 2 times x plus 1. We can factor a 2, the greatest common factor, out of the denominator of the first expression, giving 2 times x squared minus 4x minus 12. For the numerator of the second expression, we can factor out a 2 again, giving 2 times x squared minus 36. And for the denominator of the second expression, we can factor out a 3x squared, giving 3x squared times x plus 1. We can then further factor the denominator of the first expression. The x squared minus 4x minus 12 can be written as x plus 2 times x minus 6. And the numerator of the second expression can further be factored, x squared minus 36 being a difference of squares, giving us x plus 6 times x minus 6. We then reduce, and I'm going to use some cross-reducing here. We can cancel out the 2's on the denominator of the first expression and the numerator of the second. We have the x plus 2 on the numerator and denominator of the first expression. We have an x plus 1 on the numerator of the first and denominator of the second. And we have an x minus 6, can also be cancelled on the denominator of the first and the numerator of the second. This gives a final result after all of the cancelling of x plus 6 over 3x squared. Then, for the non-permissible values, we have to look at the denominator of the first expression, but we also have to look at both the numerator and denominator of the second expression. This gives all non-permissible values of negative 6, negative 2, negative 1, 0, and 6. Note the x equals negative 6 corresponds to x plus 6. For negative 2 corresponds to x plus 2. For negative 1, that corresponds to x plus 1. The 0 corresponds to an x. And the 6 corresponds to an x minus 6.